Hello, everyone. Thank you so much for joining us today for this webinar on AI enabling new mindset for electronics R&D. So we are here today with the great people of Quilter. You already know Ben Jordan, I'm pretty sure. And we also have Sergiy Nesterenko, who is the founder and CEO of Quilter. Thank you so much, guys, for joining us today for this webinar. Really looking forward to that. Just so you know, on the call, we also have Darren and Will from Quilter who can help answer the questions or at least monitor. And we have from the Sierra side, Steve Carney, who is our R&D manager. So, you know, if you have any questions about that, he can answer for sure. Thank you so much, Steve, for joining. Okay, just to give you like a little bit of background to why we're doing this webinar. So as you know, Sierra Circuits has known Ben Jordan for many, many years, right? And last PCB West, Ben came to our booth and he wanted to introduce us to the Quilter team and basically tell us about the amazing things they are doing. And we were very impressed. So we even did a webinar with Sergiy and Ben, a podcast. I'm going to publish the podcast next week. And okay, now we're doing a webinar. Thank you so much. You can start, Sergiy.
All right. Thank you so much for the introduction, Lucy. So my name is Sergiy, founder and CEO here at Quilter. Before founding Quilter, I was an electronics engineer at SpaceX for about 5 years. I started off in the EMI group and then switched to the radiation effects group, and really, designed a lot of boards, helped the team design a lot of boards. And ran into a lot of kind of the common challenges that we all run into when designing electronics, which was really the inspiration to start this company and to try to push the technology forward. So we've been working on our side of things for about 4 or 5 years now, and are kind of happy to be starting to share it with the world a little bit. And so I'll let Ben introduce himself a little bit. I'm sure most know him, but nevertheless, for those who might not, Ben, if you could say a few words.
Hi, everyone. Yeah, for those who don't know me, I'm staff electrical engineer at Quilter, and I joined this company because I could really see what Sergiy's vision was, and the Quilter team, for where hardware design at the board level was going, was really in line with thoughts I'd had for a long time, but I wasn't at the time going to make it myself, being more of a hardware designer, and I could just see this is really going somewhere. So I wanted to get behind them. I joined Quilter at the end of April last year. And before that, I had a few years as a contractor. Before that was a senior product manager for Fusion 360 Electronics over at Autodesk. And before that was actually with Altium as a product manager and product marketer for almost 16 years. So kind of an EDA guy, and very opinionated about where I think this technology could and should be helping us. So I'm very happy to be joining the webinar today as well.
Sorry, I forgot to mention a couple of things. So everyone, I will send you the slides and recording this afternoon. And also, Sergiy and I were discussing before we launched the webinar. And we were thinking that we would like this to be more of like an open discussion. So if you guys have any questions during the webinar, feel free to ask in the Q&A section, or you can even do something. You have the option to raise your hand. And if you do so, I will let you unmute yourself. So you can just unmute and talk to us directly and ask your questions, which I think is pretty cool. Thank you so much for doing that, Sergiy.
Yeah, no, of course. I really want to welcome that as much as possible. I don't like delivering a monologue any more than anybody likes listening to a monologue. So by all means, everybody, please, easy questions, hard questions, whatever comes to your mind, go for it. We're all open for a discussion here. All right, well, so without further ado, let's jump in. So the kind of thesis for this discussion here is that time matters, right? Time matters a lot. So it turns out, and this is not necessarily obvious to folks, that time to market actually drives cost overall for a company a lot more than the budget to develop something, right? So if you consider these two scenarios here, right? If you're developing a product and you develop it to budget, to a strict budget, but it arrives 6 months late for one reason or another, overall, a company that produces that is estimated to have a 33% profit loss. But in the other scenario where you go over budget on designing your product, but you deliver on time, you end up having only a 4% profit loss in comparison, right? This is a study by McKinsey, which we'll source, that the folks are, of course, welcome to review. But the point to make here is that being late to market is a lot more costly than the extra budget to get to market on time, right? And so a part of what we want to kind of convey here is that there are new capabilities and new tools that are coming onto the market, new capability both on the fab side from Sierra, which we'll talk about, that we're super happy exist, and of course from our side and other startups that are coming online that allow us to make this more possible, right? To deliver projects on time, ideally not over budget, but if they have to be, then so be it. And the second thing that kind of implies is that you need not only to look at the tools that kind of make this possible, you also need to look at the culture, right? So there's a discussion that we should have as hardware developers about how we run hardware development processes and how we leverage new tools to change how we approach the process in order to kind of achieve these results, right? So one of the places where this has already shown up, and this is nothing new, but it kind of further reinforces the point about time, right, is this switch that has happened in hardware from, the waterfall design process to the agile process, right? So for those who might not be familiar, the waterfall process is this kind of a traditional concept that you have certain sequential steps that need to happen. Each one needs to happen perfectly and be locked down, and then you pass on to the next step, right? So in this case, like, you're starting with a concept, then you go into a design phase, you lock down the schematic, review it really, really carefully, pass it off to layout, review that carefully, simulate it, then you go through your bring up and so on and so on and so forth, and you do this sequentially. And the kind of the issue that comes up is that almost without fail, all of these individual steps end up being late, right? Things take longer than you think. And furthermore, a lot of times you discover issues in the previous step once you've started a subsequent step, right? You discover a schematic issue in layout, or worse, after the board has been built. And so for that reason, one of the historical kind of culture shifts that has happened is the introduction of agile in hardware development, which is basically just this concept of iterate fast, right? Start with a concept, develop and design a solution as quick as you can, build it as quick as you can, and test it. Learn from that test, and do it again and again and again. And this, relaxes a little bit the constraint on getting everything perfect on any individual step, and allows you to discover the unknown unknowns that you tend to discover once you get to the test steps, right? And since this process has been kind of run at multiple companies for a while, we have some data to show that that it's actually producing really good results, right? So a couple of studies here that we can source to, again, to McKinsey and Scrum Inc. and a couple others in the resources, that are showing that approaching hardware development this way, with this kind of agile mentality, can improve time to market by as much as 60%. And I think in my notes here I have that some departments at John Deere were improved by like 80% because of this. So the culture shift to developing hardware quickly is just as important as the tools that make it more and more and more present, right? But the problem is that at the end of the day, like, you can make organizational changes all you like, and that doesn't change the fact that hardware is ultimately hard, right? So, as an example, PCB layout just still takes weeks for most boards, no matter how you spin it, right? Even the simplest, easiest board takes a day, and some boards take months. And no amount of, Jira tickets is going to speed that up necessarily, right? We also have in this industry a significant shortage of engineers, right? Everybody kind of tells us when we speak with their companies that there's never enough PCB designers. This is partially because we're not graduating nearly enough electrical engineers, partially because the PCB designers who are out there today are an aging population and starting to retire. at the end of the day, it's hard to predict all the possible issues that are going to happen with the design. And so, debugging, bring up validation, compliance testing, EMI testing, and in aerospace companies, obviously, hundreds more tests take a really long time. And all of this just forces those loops to be slow. And so because of that, you can only get so many iterations, and kind of Agile hits a limit from just an organizational perspective. But the thing we want to challenge here today in particular is that some of these assumptions that have been true in the industry for some time are really starting to change. So, for example, taking a nod here to Sierra, which they'll speak to this a little bit more in a moment. Production of PCB and PCBA has really, really, really sped up, right? Like most people we talk to at Quilter designing boards assume that, getting a board back from fab is going to take at least, a week or two. And especially if you go down to, thinner trace in space or 6 layers or more or so on and so forth, then you're looking at a minimum of 2 weeks. And that's just no longer the case, right? At this point, and I'll let Sierra speak more to this, but they have fast turn capabilities that go much, much more quickly than that, which enable us to look at new capabilities. Sierra is also pioneering automation of DFM and DFA so that we can get feedback on the designs much more quickly rather than waiting for a manual CAM review that allows us to shorten these loops. And aside from fabrication, on the design side, there's a wave of new companies coming in to tackle these problems as well, right? So aside from us, companies you should probably know about, like DeepPCB, JetX, Flux, CircuitMind, Celis, Dempaflux, and a bunch of others, are starting to tackle various parts of the design process and asking, how quickly can we get a first version out, right? So in particular, shout out to CircuitMind, who focus on how do we go from a conceptual block diagram of what product we want to a selection of parts and an actual drawn schematic, ideally automatically, right? And so that's something where, instead of taking a few weeks even to research parts in DigiKey and to draft up schematics, read a lot of data sheets before you can even attempt doing a first build, potentially you can have a first stab almost instantaneously if you can just draw the block diagram. And of course, other companies like us are focusing on a layout, which we'll talk about a little bit more. But then there's also companies like Dempaflux focused on EMI, EMC verification before build. And so what we're really seeing is that all throughout the stack, starting from a block diagram of what product you want to build, through schematic, through layout, through simulation, EMI verification, through manufacturing, all the way back to a board on your desk, all of those are compressing, right? All of those are potentially going from weeks to even hours in some cases. And so we really have to question, what does that mean for our kind of cultural development process? How do we iterate more quickly, given that that's possible? And how should the kind of overall process of designing products change? So I'll let Steve Carney speak to some of the new capabilities that Sierra is pioneering. We really wanted to introduce and make this point here because we find from the folks we speak with at Quilter that most circuit designers and electrical engineers are just not familiar with the state of the art of what fabs can do, and we're really excited for this to be more prevalent and known.
Okay, hello, I'm Steve Carney. I'm in charge of research and development at Sierra Circuits. I've been building boards for almost 50 years now. So what we're seeing right now, we're seeing a definite evolution in our board manufacturing. What we're seeing is, of course, everybody wants to push for smaller and tighter line in space. One of the things, we have two things that are helping us out with this. We started on developing some embedded trace technology where we're actually trenching into the dielectric and fill plating the traces. This was an alternative to the modified semi-additive processes that are all surface. What we found on there is if you get into like a 1 mil, 2 mil line, the adhesion surface adhesion is bad. So what happens is you see the pictures look great. They're on an outer layer. When you're building a multi-layer and you're trying to heat up resin and push it into those tiny areas, the traces have a tendency to basically move around with the tide. So by actually embedding them into the surface, everything is really stable. We don't have any sidewall exposure to the etchant. And probably most important, that becoming more of an issue is the surface roughness. So we're fully additive in the trace, so we don't have any dendrite structure on the copper. So even if you start with, say, a 3-micron foil for a semi-additive, you still have the dendrite structure. You also have the oxide treatment for adhesion promotion during lamination. So all that goes away, so we end up picking up speed. Another thing that we're seeing is there's a number of new materials that are just starting to come out on the market. They're primarily high speed. They're referred to as buildup films. They're specifically designed for sequential lamination, laser via. They have very low thermal expansion. They're very stable. They'll withstand 4, 5, 6 lamination cycles, which the standard products that we've been building with won't do that. So those are helping quite a bit. We're dealing with new resists. Our equipment now are laser direct imagers. They're the newer style. They have capabilities down to a 1 mil resolution. We're dealing with new resists that will get us, they too have a 1 mil or below resolution. So these are the areas that we're working in right now. So we're building 2 mil line in space, standard surface in production now. And this primarily has to do with the new resists that have become available. And then we're getting into, we're going to be releasing the 2 mil embedded product probably early next month, and we'll have a 1 mil line in space product coming out in probably early mid-spring. So that's where we're going. We're driving more towards substrate like PCBs. This is where we see that primarily the growth in the US industry is going. So we're trying to kind of stay ahead of that curve.
Thank you so much, Steve. That's awesome.
So anyway, that kind of covers it. Anybody have any questions about that? I kind of went through it real quick.
Steve, I'm curious if like you can share a little bit about you know, the biggest impacts to time, right? I think one of the focuses we have here in this discussion is how do we get boards turned around quickly to enable fast iterations. And so specifically looking at Turnkey Pro and looking at the, you know, 5 to 7 to 10 business days turnaround time, how do we keep it at 5? What are the most important variables?
So probably the biggest thing that helps us is when somebody gives us a design, they have really explicit fabrication notes. They tell us exactly what they want up front. I will say some of the quicker turns, those are for what we refer to as a single lamination, typically 1 or 2 drill files, which is a more basic type of board. When you get into laser via sequential lamination, that you know, obviously stretches the lead time out. Sierra does handle everything just because we've been at, you know, quick turn prototype so long, we handle everything quick turn. But I think to address your question, the actual manufacturing, that stays pretty constant, where the biggest issue for delays is that we get information from customers that isn't complete, or we have design issues from them that have to be resolved. And that's usually what stretches things out the worst. So we do have, we'll take your customer's image files and then we run them through our CAM software. And we have a lot of things that are scripted and automatic now. So we'll actually run the customer's data through our CAM system, and it'll highlight any design violations, any design issues, things like that. So then we have to go back to the customer, and then we start working back and forth for, various, how do we resolve these issues? So that's usually what takes the most amount of time, where we start losing time. So if we get everything clean up front, good explanation, clear understanding what, the customer wants, then things run through pretty quick.
Awesome. I think it's really worth highlighting here that like all these amazing advancements in materials and process and so on and so forth are making what, even 10 years ago would have been considered, super advanced, low tolerance manufacturing practices, something that's available within a week, right, or less. And that's really remarkable.
So actually, it's changed faster than that. So, like I say, we've been working on our embedded trace technology for 8 years now, and it's really just been in the last 6 months that these materials are really starting to become available, and we managed to overcome the problems that we always saw with it, which was basically primarily everything that we've had to deal with up to this point has been had glass reinforcement in it. So that interrupts a number of things when you're getting down into, the basically sub 3 mil. There's a new category coming out called ultra high density, which is defined by IPC as 2 mil line in space and below. So the standard subtractive printed circuit board production, been around forever. That pretty much hit the wall at 3 mil line in space. So it's just now that basically within less than the past year, these materials have become available, and now we can get down into the smaller line in space, higher density. So another thing that Sierra is kind of unique in that helps with us, as far as our delivery time. We have a huge amount of really expensive equipment that's redundant. So we can get by with one, but we end up having 2 of them or 3 of them, just so we don't, things happen. We have a lot of equipment now that's using lasers and cameras and all kinds of stuff. So the equipment to produce these types of boards, it's definitely gotten, expensive and a lot more complicated. So, that's one thing that we do have that a lot of people don't is, just a lot of high-end equipment to support this kind of technology. Another thing too is, we're always available. If you're working on, somebody's working on a design, they're more than welcome to talk to us up front. So once they submit a package, we can already, cover some of the issues that they're concerned about. The standard stuff is pretty simple. If you start pushing, like one example is, a standard construction drill to copper is 8 mil. We can get that down to 4 mil, but you need to do a number of things with the materials and the stack ups up front to be able to get down to that small of a space. So really it's just, a matter of asking us questions, and, we're glad to help. And if you want to push beyond what's outlined in the standard capabilities, just let us know and we can do that.
Hey, you know, Steve, this is actually a really good segue into what's possible in the design tools now. And so I want to talk about that just a little bit, this kind of supplement your point about all the possibilities here. And to underline that there's now this collaboration we can have between design tools and fabricators, right? And facilitating getting these choices, these fabrication and stack up choices right to begin with, and also having that discussion faster with your, with your fab and with your design engineers. So real quick, I'd like to jump into a demo of Quilter just to show actually how in Quilter we can kind of account for all of these different possible manufacturing limitations, different stack up strategies, different materials, and automatically see which of those really help the schematic be brought to life very, very quickly. So I'm going to share my screen on a different window here real quick and just go through this really quickly. So at Quilter, what we do is we focus on specifically converting your schematic into a layout as quickly as possible. And so, of course, that's kind of the piece of the pie where, these decisions about, manufacturing materials and so on and so forth start to matter. And so here's kind of how we think this could be done in collaboration with manufacturers. So what we're looking at here is just Altium. At Quilter, we try to work with the existing tools such as Altium, such as KiCad, in the future Cadence, and so on and so forth. And we try to leave the process of generating schematics alone, right? So that engineers who are used to doing this for their entire lives don't have to change how this works. And so in this case, what we're showing is a board that we're building internally that's basically got an FPGA, some power control, a whole bunch of sensors that it'll measure, kind of like a big board IC test, that you might see in aerospace or automotive or other applications. And then a USB connection for basic communications and a screen and some indicators. And so this schematic is kind of defined as normal, with the standard hierarchical schematic definitions. And the next thing that we ask users to do is to start the board file. So users have to draw what outline they want for the board and potentially do things like pre-place connectors that are defined mechanically, because there's like a certain part of the assembly where they have to go, or so on and so on and so forth. So all of this ends up being given to Quilter, which is just basically a website. And Quilter will then process these files and begin a conversation about how we can actually design this, right? So Quilter will take the direct Altium files and understand that there's certain components and certain pins and certain rooms that have been defined and so on and so forth. And it'll go through a conversation with the user about effectively the constraints, right? But one of the changes that we're introducing is, instead of thinking of constraints in a board as effectively design rules, like what is the trace and space that we must respect, how far, what is the minimum distance for two high voltage nets, and so on and so forth. Really, all we need to define with Quilter is the actual physics that's happening, right? So the fact that we have bypass capacitors that are meant for certain pins, the fact that we have differential pairs that have to be designed to a certain impedance control, rather than saying exactly what those trace thicknesses and separations are, crystal oscillators, high currents, and so on and so forth. And what that does is that allows Quilter to kick off this optimization process. And so this is where things get exciting. So when you run Quilter, what it can do is it can automatically go through potentially multiple different fabricators worth of designs, but also, as Steve was alluding, multiple different design choices in terms of design rules, right? So we can, for example, attempt a 2-layer, 4-layer, 6-layer, 8-layer, 10-layer stack up. And if it's not completely obvious which one of those is going to close at the beginning of a design, we can just try all of them. Same thing for trace and space, right? Perhaps we can get away with really conservative, 5, 6, 8 mil trace and space, or perhaps for some board we need to go down to 4 mil or 3 mil or even 1 mil, as is now becoming possible. But the point is that that's no longer a decision that you have to make as a schematic designer, as an electrical engineer. That's something a tool can just figure out for you, right? And so that enables engineers, in the name of speed, to focus on getting a first draft of a schematic and doing a 1-hour run to get a possible layout as quickly as we can, and then getting it to fab so that they can get the board back on their desk within a week or less to start learning about the unknown unknowns that exist. The final step for Quilter here, just to show the concept, is to download the board, and that brings you back into Altium. And so at that point, you are back in the same CAD tool you've always used, that you can then modify the board with, or create Gerbers to send to fab, and so on and so on and so forth. And for this particular board, this one we actually built. And so I'll pass it over to Ben real quick to talk about this whole process and how it went, with literally this exact board working on his desk.
Yeah. So it is an eye-opening experience, having come from many years of, IPC advanced certified, PCB designer, degree qualified electrical engineer, learning all this stuff about SI, PI, and acid traps and teardrops and all the limitations we used to have on manufacturing that are actually a lot of that advanced technology for manufacturing the board is what's also going to make, or I should say, loosen the constraints to a large degree on how a board could be routed, how parts could be placed. So let me just switch over though and show you, because everyone's probably curious. So I have this webcam. This is the actual board that Sergiy was just showing you. So I went through this process. I designed the front end of this. Any difficulties I've had so far in bring up of this sensor array board with an FPGA with built-in JTAG debug capabilities, power management IC, all of those things. Any of the issues I've had so far were my own design errors, and the board actually came in. I actually chose a 6-layer candidate, not because I needed to. There were some 4-layer candidates, but I chose the 6 because I wanted the one with slightly larger via holes, and it wasn't any more expensive to get it made and rapidly prototype. So I had these boards. I had my several Quilter fully routed and placed candidates overnight. I made my choice, and then within 2 weeks I had fully assembled prototypes. I could have had them a lot faster had I gone with a domestic rapid service. Like if I'd actually gone to Sierra for these, perhaps I should have. I could have had them within a few days on my desk, ready to start bring up. And so, and you can see, I've got the step 1, make the light blink, right? So I've got some RGB LEDs there doing some basic debug. So this thing's actually working. If I don't know how to share my screen in Zoom. It's been so long. Here, let me click share, and I'll show you my screen 1 here. So this is actually an ongoing interactive debug session too. You can see there's stuff going on there. If I just to prove it to you, like this is actually happening. While I'm waiting for the debug session to stop and restart there for a second, I want to switch camera. I'm hoping you guys can follow the camera changes I'm making here. Where are we? Where's my controls? It's been so long since I've actually been on a Zoom. Here we are. I'm going to go to my little USB. I have a USB microscope there. So you can see there's one little wire I had to add because I forgot to tie one of the unused feature pins low on the power management IC. So I had to very, very carefully with a needle tip soldering iron put that wire on there and tie it to a nearby ground. And that was not a Quilter error. That was me as the EE. So, I'm experienced, but I'm flawed. And this,
for what it's worth, like just to jump in on that point, Ben, like the two of us reviewed the schematic together and both of us missed it. And the fact is that happens. right? The number of times that even at SpaceX, we would have thorough design reviews of all the different things in the schematic as thoroughly as we can. And inevitably something comes up during bring up, something comes up when you hook the system up together on a HIDL test bed, or worse, when you're actually getting it into the vehicle. It just happens. And so the key to kind of development mode, right? This idea that we want to, while we're in development, iterate as quickly as possible, is that development mode is the way you answer your unknown unknowns as quickly as possible, right? Being very careful with simulation and analysis is an important way to answer all of your known unknowns, but there's always surprises. And so this is the main point, right? That a mistake like that isn't found at the very, very end when you have no more time for another iteration. It's found ideally 2 days after you're done with your schematic, right? That's really, really critical.
Yeah, 100%. And I already have, 3 or 4 notes of things I would do different on a respin on this. And back to the original point, like time is the most precious commodity for anyone in business, anyone doing electronics design, you name it. Time, even in our personal lives, time is the most precious thing that you just can't make more of. So that's what we're really about here. And the way we do this, and using physics as the feedback loop, Sergiy, I don't want to steal your thunder on that, so I'll give it back to you in just a moment. But that's why we're doing things the way we're doing them at Quilter. Is we don't care. I don't care, honestly, what the routing looks like. If I want to hand route a board and I have time to do that as an experienced seasoned designer, I will do that every now and then to find that state of flow. I love it. There's not going to be any lack of opportunity for me to do that here and there. But I'm under the gun to get real results here. I want to have this board ready for a demo. I want to be able to show it fully operational. I'm not having to put this through EMI, but I would actually put money on it. I would bet that this board would pass basic EMI testing. And the reason is I know how much we've put effort into Quilter on the front end to understand those physical rule checks. It knows today what we're up to. It knows basically what a DC to DC converter is. It knows what high current traces are. And we do work with actual manufacturer DFM input as well. And so this board is made with proper grounding, proper planes, proper microstrip lines. So although the traces look like 90 and 45, octilinear traces done by automation, they're not going to radiate. I know they're not going to radiate because they have solid, unbroken grounds directly under them. And so, I'm not too worried about that. And again, like this is about getting that first article up and running so I can build the application. And later on, if we want to, we can hand tweak, hand optimize if we feel like that's necessary. But this is really the future of like saving time, getting to bring up as fast as possible.
Yeah, so speaking to this, Ben, I'm seeing a couple of quick questions in the chat that are on topic, so I'll just answer those real quick. One quick question from Adam is Quilter qualified for ITAR projects? In short, yes, if you come and talk to us first. We have deployed Quilter with aerospace companies that have run ITAR projects through this. But our open beta that's just available to the public is not ITAR certified. So that's something where just please reach out to us and we can have a discussion about how to facilitate ITAR. The second question is from Alexei. Does Quilter algorithms consider EMI, signal integrity, and power integrity for the layout? In short, yes. So as Ben was alluding to, the way Quilter works is a big reinforcement learning loop where we define what are all of the signals on the board. Then we iterate by creating layouts. And as we create those layouts, we grade them with a whole bunch of physics outputs, right? So we run a whole bunch of checks, kind of like DRCs, but really we think of them as physics rule checks to figure out, are the designs actually up to standard? And you'll see that on our site, right? In terms of what challenges we can handle and how we check that they've been done correctly. Peter asking, where is the AI part in Quilter? So Peter, the AI part is basically this iteration of reinforcement learning. So this idea that neural networks are proposing these designs, and they can, neural networks have issues. They can hallucinate. They can do things that are wrong. But that doesn't trouble us because we run it against standard pre-scripted physics checks that then verify all the physics of the board that is done correctly. So the AI part is really responsible for coming up with designs, and then it is punished or rewarded based on the physics of it. For George, please show the routing the PCB file so we can see it. Ben's showing it a bit, and we're also going to eventually publish this board, open source all the files so you can look to your heart's content. And for what it's worth, we're improving rapidly. So what you see now is going to be worse than if you upload it today. Let's see a few other questions here. Cost structure, Lee, for now, so Lee Davis asking, what is the cost structure? For now, we are working with early design partners. So if you just want to try it out and do some small, easy boards, we have an open beta. You're welcome to try. But for more serious engagements with enterprises, it's a kind of one-to-one discussion about, what is the company? What requirements do you have? Do you need on-prem? And what kind of support will you need? And it's really just a discussion between the two companies at that point. Let's see other questions. Perhaps there's quite a few questions here. So let me perhaps drive through the rest of the couple of last slides that we have here, and then we'll jump into these awesome questions that we're getting, just because I want to make sure that we cover everything. All right, let me grab the. But please keep the questions coming. These are great.
They are excellent questions.
I just want to make sure we save a lot of time for them and don't rush through them. All right, so kind of to drive the point home here, so we can get back to the questions. Key thesis here is, there's two modes that we really should be thinking about as designers, right? We need to be thinking about production mode and development mode as separate things, right? Production mode is about, I'm going to make 1 million units, and they have to be perfect, and they have to be cost optimized. And that is the point at which it makes sense to nitpick every last detail on the board and be super careful and make sure it's super right and take your time. No question about it. But the key of development mode and of iterating quickly is that the best way to get to that final product that is going to be scaled in that kind of quantity is to build a lot of iterations of it. And so we're encouraging organizations to think in these two mindsets, right? When are we in development mode, and how do we iterate as quickly as we can to discover as many unknown unknowns as possible, talk to the fab as soon as possible, so on and so forth, versus, okay, our design is actually locked down. We actually know exactly what we're building down to the last detail. Now let's optimize it perfectly. And those are two different modes. So this is actually starting to already happen, right? At Quilter, as I kind of alluded, we do talk to a lot of enterprises about using Quilter, and lots of folks have a lot of different ideas. And so I'll share kind of, without exposing who's who, some of the ways that some of the bigger companies in the space are starting to think. And the thing that this creates that is possible between the fast turn prototype of Sierra and the fast design that Quilter can provide is effectively daily or even more frequent checks or designs for your board, right? So imagine if you have daily updates to your mechanical constraints, right? I'm sure many people here have been in a situation where you've designed a board, you've sent it to layout, you've spent a month in layout, and then somebody comes and asks to move a connector by 1/2 inch. And you have to say no, because it's just way too big of an impact, or you're going to take a schedule hit, be late to market, and suffer the profit loss, right? Now, if we can run this whole engine of going from schematic to layout to SIPI analysis in a matter of like a daily cycle, and maybe produce a board once a week, all of a sudden that mechanical change is not a big deal, right? You just punch it in for the next nightly build and you see if it breaks anything, right? Another example here is the SIPI folks, right? You can't run a simulation until you have a layout. And by the time you have a layout, the pressure is to go to fab and get the board built as soon as possible. So there's not that much time to really analyze it a lot. But if you have a nightly build of your PCB, your SIPI team can start running simulations on critical aspects even before the schematic is locked down, right? So the point here is some of the best companies in the space, what they're already doing today is on a daily basis as they're making their schematic, they're just running Quilter to see what it's producing. On a daily basis, as they consider different form factor options, they're just running it. On a daily basis, as SIPI engineers look at the board and say, this doesn't seem right, they talk about how do we influence it and rerun it. And instead of having this waterfall of, system diagram, then schematic, then layout, then SIPI, then build, and it takes 6 months. It's a daily discussion where each of those parties is already having an impact, right? And that is super, super powerful. And the best companies in the space are taking this to the extreme, to the point of trying to automate all of it, and to loop even faster than daily.
Yeah, I guess I look at it as, you can do so much more if you can just get those insights sooner. It's all about getting insight as fast as possible. Yeah.
100%. And just to reiterate, it's the culture of this process that matters just as much as the tools, right? So in addition to Quilter, in addition to Sierra, in addition to all the other startups that are coming out, it's how do we as a business, how do we as a culture invite all those groups to the table at the same time, to have that discussion at the same time, to encourage failing quickly, to learn quickly, right? That the main point here is that success really should be measured not in the cost of a certain task, right? Not in the fact that I saved the company $100 by optimizing some part of the board or eliminating a couple layers, but really in how fast I got the result done, so I can unblock all the other engineers in the group to make their impact, right? So I can give the board to the firmware engineers, start writing firmware. So I can give it to the radiation team to put it in the beam. So I can give it to the EMI team to get a pre-compliance check, right? Speed is far more important than optimizing every detail in development mode. So I think we went through Sierra circuits a bit. Lucy, did you have a couple more slides you wanted to touch on here?
Just very, very quickly, because I see you guys have a lot of questions. So most of you know we are located in Silicon Valley, right? So we do manufacturing in Sunnyvale and we do assembly in San Jose. So everything is in-house, perfect for you. I just want to talk just a little bit about the advantage of working with us. When you place an order, we have this awesome customer portal where you can basically track your order, but also, and this is where it comes in very handy for you, our DFM and DFA engineering teams are going to discuss with you potential issues they see in your design that could cause manufacturing delays and errors. So this is a great way for you to interact with our engineers and maybe fix your design if necessary. We have coming up something called Raise Engineering Change Order. We are calling that ECO. So what it means is very soon you're going to be able to raise a ticket even like after you place an order. Let's say we're working on your job and you want to make a change. So you can raise a ticket. Our engineers are going to see that and make the changes accordingly, even if your board is already on the floor, which is pretty cool. So we are ITAR registered. We work with all type of industries and applications, from defense, aerospace, medtech, automotive, telecom. One of the very cool things about Sierra circuits is that we can get you to plus minus 5% impedance if you come to us very early on in your design stage, right? Don't come to us at the end. Just talk to us at the very beginning of your design and we'll get you that. Finally, we also have some PCB design and layout services should you need any help. And well, you already know resources, but you should check out our blog, design tools, knowledge base, design guides, and we also have Sierra Connect, which is our forum. Okay, that's it.
Okay, thank you, Lucy. I'll make one last point for Quilter, and then we'll jump into all the awesome questions that we're getting here. So just to make it explicit for everyone, Quilter is available to try for any of the cases that you guys might want to look at. So we have two ways that companies tend to try us out. One way is through our open beta. So if you just go to quilter.ai, you can just log in, make an account, start uploading designs today, no problem. This is all private sandboxes, so your designs are strictly controlled, not shared with anyone. I know this question already came up, and I'll speak to it again, but we don't train on your designs. We don't share that with other customers. So your data is kind of strictly protected if you upload it to Quilter, and it won't go anywhere other than our servers. And then we also have what we think of as a white glove evaluation. So for enterprises that want to actually take it for a spin, get a board through build, quantify its performance, and really see if we can fit your specific designs with all the needs that you have, reach out to us and schedule a demo, and then we can talk through how we can basically help you with an evaluation, how we can set up Quilter for you, walk through the whole design, walk you through the benefits, and actually build a board and quantify it and see if we've met the standards that you would need to start utilizing it within your organization. So with that, I want to make sure we have plenty of time for questions.
Yeah, there's a lot. There's 16 open questions in the Q&A panel. So I'll jump in and do the first one. Does Quilter honor routing constraints, and can it take pin delays into consideration? For example, strobe and byte lane delay matching in DDR. This is something we're actually working on. As of today, we're doing differential pairs for things like USB. And so we will route differentially. We're not doing length matching or delay tuning yet, but that is on the roadmap for sure.
Yeah, we should mention probably one of our next projects that we're looking at building is actually proving out USB 3. So the fun idea here is just to make a USB 3 hub that we can test and that we can pass around to prove at least that basic piece of it out for others. But certainly a lot more. We've got some good surprises coming this year in terms of, I think, what would be surprising capabilities. Let's see, we've got another question here. Do you have a case study you can discuss or share where a layout was created by Quilter and run through EMI MC compliance? This is by Mehul. Not yet. So we'll certainly do that with some of our designs. Bihasa, this sensor board we designed might be a candidate for us to do for the first one, or maybe we wait until we have something even a little more high speed that's a little trickier. But we'll certainly do that. I see a question from Lee. Can this tool assign dedicated planes to power and ground? I assume this is initial setup instructions by the electrical engineer. So Lee, we have kind of two principles on this in general. Quilter is kind of designed to walk the line between folks who need Quilter to just do it for me and folks who want to have a lot of control. So if you, as an electrical engineer, don't specify those kinds of constraints, then Quilter can, automatically look at a lot of different stackups. And of course, a part of important stackup is the grounding strategy, right? Which planes are going to be grounds, which planes are going to be power, and so on and so forth. And so if you'd rather just throw in the schematic and let it be done, we can take care of it. But what you'll see over the next couple of months is we're going to give a lot more control to the electrical engineer where you want specificity. And so you also will be able to specify a specific ground plane, a specific power plane, or perhaps even in the future, draw parts of the power distribution yourself if you don't trust that to Quilter. The general philosophy we operate with is Quilter finishes the job. So if you give Quilter the entire job to do, it'll do the whole thing. But if you don't trust Quilter to do pieces of it, you can do those pieces. You can do the high-speed piece, you can do the RF piece, you can do the power piece if you want, and then let Quilter do the easy stuff, right? And either way is kind of okay. Let's see here. Okay. Next question I'm seeing is from Dan. Oops, sorry, these are scrolling on me a little bit. Okay,
Yeah.
Next question I see from Dan.
It's good to keep the questions, if you can, into the actual Q&A panel, because there's two sections now. We're seeing them. One's just in chat, and the other is in Q&A. But it's easier.
Oh yeah, I'm only looking at the Q&A.
Yep.
Yeah.
Go ahead.
Okay.
Sorry.
All right. So Dan asks, if I run a board through Quilter and it learns new things, are these learnings shared with your other customers? Absolutely not. All right. So Quilter, in general, tries not to learn, or generally does not learn from human input. We learn from this process of trying a board and then evaluating it with the physics rules, right? So the best analogy, if you want to see this, is in 2017 when DeepMind beat the world champion at Go, right? That was a case where reinforcement learning was allowed to basically play against itself in the game of Go, and eventually got so good that it beat the best humans on Earth, right? And so the hope is to do the same thing with Quilter. The hope is to allow Quilter to play the game of PCB layout against itself and to be scored by the physics. And eventually, hopefully, it gets better and better and better and eventually matches human ability or better in designing these things. And so for that reason, no, we don't take anything we learn in your design and pass it around because we're ultimately learning from just throwing challenges at it and letting it figure it out. Okay. The next question I see is Olivier. Oh, sorry, was there somebody
Yeah,
want to
you
speak
have
up?
two questions at the top that you missed, one from Philippe and one from George.
Oh, okay. Thank you. Yeah. Oh, I see. So I just go to the very top one. Thank you. Okay. So Philippe asks, it's one thing to send out a board file to the PCB house, but to provide the schematic to an outside entity typically violates company policy in sharing IP. How do you guarantee security? And the second question is about crosstalk. Sure. Yeah, it's a great question. So Philippe, the first question is a conversation on a case-by-case basis, right? In general, we've handled schematics that fall under ITAR, that fall under all sorts of security restrictions, and so for plenty of organizations, that's not an issue. For some, it might be more of an issue, and so one of the ways we potentially get around that is to do on-premise deployments. And so what we can basically do is set up Quilter on your servers so that your schematics never leave your premises, and that's that. So that's one way that we get around that in principle. Another thing is that we really use schematics to determine what are the signals on the board. And that is kind of just a shortcut, right? If you want to obscure the schematics, all that it means is that you have to take more time to configure Quilter. And so that's a second option as well, to maintain security over the schematics. And then the second question here is, what about crosstalk? Again, the principle to handle here is that we try to evaluate all of the signal types that we understand and know about with different levels of physics rule checks, right? So to reiterate in this point, there's, roughly speaking, three ways to approximate crosstalk, right? One is the standard rule of thumb of like the 3 widths rule, right? Which is a very easy and quick check, and something you can do. The second would be to do a quasi-static approximation and to capture like the mutual capacitance or mutual inductance between two traces. And then the third would be a full wave sim. Right, and so what you'll see with Quilter is, today we fall towards the simpler end of that spectrum because we need it to be fast, and we have a lot of things we need to build out that aren't in the tool yet. But over time, we're going to push that up the stack to more and more accurate simulators to eventually cut out as much margin as we can out of these designs once we kind of gain confidence. Let's see. George asks, I need to confirm your autorouter is using design rules that were placed into Altium PCB file. Is that correct? So George, not exactly. The principle that we follow is that when we onboard an enterprise, we go through what fabricators they use and what stackups they typically use. And then we pre-configure a whole set of different design rules, right? So for example, as Sierra was just showing, if we can fall into a design that can be done with the turnkey specs, right? 4 mil trace in space, up to 10 layers, that's awesome. That means we get the board to you sooner, and that's great. If we have to go down to a crazier trace in space like 1 mil, okay, it's possible, but obviously it's going to cost more, it's going to take longer. And Quilter's philosophy is, now that layout is done entirely by computer, why not try both? Right? Why not see if we can complete it one way or the other? Maybe we can get a big board with a bigger size done with 4 mil trace in space and get it on your desk more quickly, whereas maybe the super dense design that you need for production that has to be done with tighter tolerances will take longer, and that's fine. Now that layout is marginally free, why not do both, right? And so our goal is not to take just the design rules in the Altium file and respect them. It's to define sets of design rules that you would find acceptable for different fabs and processes you might work with, and just try all of them and see which one meets for which design, and take that burden completely off of you. Olivier asks, how does the software know each signals, analog, digital, low impedance, switching node, etc.? So Olivier, this is the part of the pipeline in the process that we think of as circuit comprehension. So what we try to do is we try to read your schematic, and eventually we're working on adding directly reading data sheets to pre-populate all of the classifications of the different signals on the board. But importantly, there could be mistakes there. And so we expose all of those assumptions to you as the user, and effectively a part of your review is to make sure that we've correctly understood that this is a diff pair, and this is a DDR, and this is a USB, and so on and so forth. And so if we got one of those classifications wrong, you can catch that and override it. Ideally, we get it mostly right, and you can go straight to layout more quickly. But the real answer to your question is that we pull it from schematics, and we will also be pulling it from data sheets directly for the automation piece. George asks, does the autorouter do length matching and phase matching for high-speed differential traces? The answer is not yet. Length matching within a differential pair and across differential pairs is like literally next on our roadmap. So that's something we'll see here pretty soon, probably in a couple of months at the most. George also asks, does it do pin swapping of FPGA pins to optimize the routing? Also not yet. Actually, it's a question we've been asked a bunch of times, and not something we've implemented yet. So for now, how your nets are defined is how we route. But that's certainly a nice optimization to have. If we can get a solution with pin swapping versus not being able to get a solution without, that's certainly something we will definitely be doing at some point. Let's see. Go ahead, Ben.
Yeah, Phil's asking, SI sims can take 3 to 5 days per run. How large a design will run sim in less than overnight? Well, see, that's where some of the secret sauce is. Yes, if you're doing a full wave electromagnetic solve on a big complex board, it can take days in traditional SIPI simulation tools. And so that's where in Quilter's reinforcement learning feedback, it's a combination of physics and some of that is simulation. And it's a combination of what we know to be physical rules. And some of it's even just DRC, frankly, from the different board layer stacks and board manufacturers that we're sort of making as targets, let's say. And so by mixing quite a few different ways of running the result through the physics, we're able to do a lot of that stuff a lot more rapidly. But it's also definitely a work in progress, and we have some geniuses on board who actually are really good at optimizing the way you get accurate enough to make a good pass-fail decision on the way a board's routed, say. That could then be backed up by a more detailed, thorough analysis. And we're also partnering with SIPI experts on this as objective third parties to test and measure things as well. So as we go, we're able to validate what we're doing is true.
Okay. And Ben, by the way, if you see questions you want to answer, just speak up. My voice definitely needs a break. So Nicholas asks, does Quilter consider specific layout recommendations that are outlined in component data sheets, or does it only lay out based on past successful experiences? Nicholas, the answer for today is just only past successful experiences, right? We really try to compute whether or not the board will work. And of course, that's a very, very difficult thing to compute. And there's plenty of things that we haven't considered yet. So it's not complete. But that is the ultimate goal. The ultimate goal is if we can put together a set of checks that reliably tells us that the board is going to work, that's what eventually allows the AI to run billions and billions and billions of iterations across many designs. And eventually, hopefully, find strategies that humans haven't considered. Right. And we see that as the real kind of next level technology unlock that we'd love to bring to the market. Is that kind of capability. And the only way to get there in the long term is to actually know if the board is going to work or not, and not necessarily just trust the data sheet. We might consider taking hints from data sheets at least as priors to optimize over. That's certainly something that's been suggested and something we've been discussing internally. But the ultimate goal is to actually know if the board is going to work. That's the real signal we got to build against. Next question from Lee. I would love to upload boards that I already designed and built, but compare how your tool compares to my design. Yeah, Lee, that's perfect. That's a lot of how people evaluate the open beta. That's a lot of what we do in the white glove evaluations is take a design you've done, let us know how long it took, let us run through it, get some giggles out of the differences between human and AI generated layouts, but then build it and prove that it works. And then consider, what that time buys for you. Right, and that's really where the magic moment happens. Next question from Yasser. Broadly speaking, how does optimization algorithms / artificial neural network work for translating the schematic to layout? Yeah, so the key point here is the reinforcement learning piece, right? So reinforcement learning happens in kind of 3 major steps, right? You have some game that you play. It has actions, it has observations, it has some state, and you can influence the game. You have some neural network, and its ability is to see what's happening in the game, observe the state in some way, and to select actions. And then you have a reward, right? Something that says good job or bad job, right? So for our case, the game, so to speak, kind of looks like a CAD program, right? It kind of looks like an Altium or a KiCad or whatever, only that it has no graphical user interface because it's not meant for a human. right? So we have kind of our own CAD under the hood that's meant for machines and not meant for humans. And then the neural networks are taking some kind of observation from the board, from this kind of CAD system. And I won't speak too much into exactly how we do it, but there's a lot of literature out there on how others approach it, right? It can be graph network observations, it can be vision observations, it can be vision transformers, it can be convolutional neural nets. There's a lot of different ways to go about it. Lots of stuff written in the literature, and we see merit to a lot of them as well internally. But then ultimately, those observations produce actions that creates a board, and then we run the DRC and the physics rule checks and give it a score. And if it's good, we make those actions more likely. And if it's bad, we make them less likely. That's generally how the process works.
Yeah, this question from, I apologize, I can't pronounce the name. So many apologies for that. Can Quilter perform any PCB layout simulations? For example, what's in ADS for extracting S parameters? The short answer is we are using that kind of physics analysis to some extent as part of our own reinforcement learning feedback loop, but that today is not something that's visible to the user. What you will get is a bunch of routed board candidates that are ranked based on various parts of that algorithm. They're ranked based on what Quilter thinks is really good, or what's less good. And then ultimately, as a user, you choose which one, and you can filter them based on things like how many layers, just like you saw in the demo. Do you want the one that goes down to 1.5 mil trace in space, or do you want the one that's 3, or the one that's maybe more layers but 5 mil trace in space, because that's better for the manufacturing process that you want to work with, for example. As far as the actual electromagnetic parameter extraction, it's probably something we'll offer down the road. But as of right now, we're not trying to compete with or replace SIPI tools at that end of the market that definitely go into a lot more depth, and you can do a lot more what if and more detailed sort of simulation. I hope I'm answering that accurately, Sergiy.
No, 100%. Definitely, like ideally we want to get to the point where we provide you with more proof that your board will work than you would typically get from a standard layout process, right? It'll obviously take us some time to get there, but it will happen. And the other plug I'll kind of make here is, in the meantime, before Quilter can provide you, hundreds of pages of documentation on every possible simulation you could want, let's build them, right? So what we do is we offer this Fab for Free program, where if you want to try out Quilter, but you're not sure that the board is going to be good or it's going to work, we welcome you to submit it to our Fab for Free program, where we'll pay for the fab costs. And what we get out of it is, we get to practice the actual build, to go through the bring up and see how it goes, to support you in that process. And if, we'd like to be able to publish it in our marketing content to kind of share with more people how it went. But then you get a de-risked way to see if it actually worked or not, and be able to perform measurements rather than just simulations on how we did. So definitely a plug there, that anybody who kind of wants to test drive this, another option you have is submit a design and then challenge us to actually build it for you. And we'll pick up the tab just to prove it out. And then one last question here I'm seeing from George. Does Quilter use the settings of the constraints manager in Altium, or does Quilter ignore this information and generate its own constraints design rules? George, yeah, for the most part, we try to generate our own constraints and design rules, right? The way we kind of see this is that ultimately the constraints and design rules come from what signals are on your board and what fab and process are you going to use. And at the end of the day, if we know what signals are on the board, we can make the fab and process a variable, right? We can try 4-layer, 6-layer, 8-layer. We can try fancier materials and all these sorts of things. And if we take in the constraints from Altium, we can't do that, right? Those are calculated for a specific stack up, for a specific impedance profile, for a specific layer set. And that's fine. We drive Quilter that way sometimes. But the real power of it comes from the exploration, right? What can we build? What are the possible ways we could approach the problem, rather than doing it exactly this one way.
Yeah, it's funny, George, that takes me back to the original documentation for the Citus router that was published by Altium when I was there actually before I went to Altium, that they had this auto router that, interestingly enough, was actually based on machine learning principles. It had come from a company in the 90s, and it was built using maybe 50 or 60 boards as training data set, using Pentium era, probably 66, maybe 100 megahertz desktop computers to build the model. And people wondered why, for years and years, the Sidus router was kind of okay, but it never really did a great job. They had the right, or similar to the right ideas. Reinforcement learning wasn't a thing back then. And reinforcement learning removes all the copyright issues and the questions about whose IP this is, because it'll only train itself on your own board each time, as it were. It's more complex and deep than that, so forgive me, Sergiy, for butchering it. But the bottom line was that documentation said, you're not going to get good results if you over constrain this. If you give this thing, you have to set up your design rules correctly and set up a layer stack, but kind of cut it some slack. If you say you have to do this crazy complex design in 2 layers, yeah, it's not going to finish. It'll get to 70% and balk, and the results won't look good. I think principally and philosophically, one of the reasons why I knew Quilter was onto something really good and wanted to join this company was, from the outset, I could see that over constraining something, it's kind of like the first mistake in using automation almost. There are situations that call for adding more input from the user, of course. We're not about not taking input, but it's about, there's kind of a mindset that what we had to do in the past was spend a lot of time setting up design rules. Whether we handed off a board to a human designer or an auto router, or a bit of both, you had to spend a lot of time configuring design rules. We're actually making that a lot faster and simpler as well. It's one of the other areas where Quilter is enabling more rapid iteration, because you don't have to be so strict. Yeah.
Do we have any more questions? Well, that was already a lot of questions, to be honest.
There were others in the chat, but I think for the most part, I think those were actually all answered in the like, they're very similar. A lot of people had the same sorts of questions. So
yeah, I did ask people to, yeah. There's maybe one question we didn't answer from the chat. Lee is asking, where is the parent company located? I'm not sure if that was answered or not.
Yeah, no, I can we can speak to that. I think I saw Will answering it in the chat, but just to make it clear for everyone, so Quilter doesn't have a parent company. We are Quilter, and that's that. We're located in here in Los Angeles, where I live. Strictly speaking, our team works remotely. Mostly people from different parts of the U.S. But it's a U.S. based company. Delaware C Corp, funded by U.S. venture capitalists, located in the U.S. And there's no kind of like shadow hidden parent company that's somewhere else, to make that really clear.
Yeah, and then in that time, Philip asked again, what are the supported board files currently? We natively support Altium, Designer, and KiCad, and we're looking at targeting the other major EDA vendors as demand increases down the line.
Yeah, to add some color to that, right? Like when we say we support Altium or KiCad, we don't mean that we take in a Spectra file or something else, right? Or ODB++ that you can't work with. Like we actually read the raw file, right? So you're drag and dropping to us in Altium's case a .sch doc and a .pcb doc. We read them directly, we operate on them directly, we return them to you directly. So from your perspective as a user, it's as if you had emailed those files to a friend, a PCB layout person, an outsourced person, an intern, said, can you please do this layout? And that person emailed you back, right? And it allows us to have control over everything, right? We can update the rules to match what we've done. We can update your layer stack up. We can update, obviously, the place in the route and the pores and all of that stuff. It gives us really full control, right? Rather than being limited to what the kind of old auto router standards were set, 20, 30 years ago.
Great. Well, thank you so much, Ben and Sergiy, for this awesome presentation. Thank you so much, Steve, for chiming in. And thank you to everyone who attended. I will send the slides and recording this afternoon. And
Awesome.
have a great day, everyone.
Thank you for attending, everyone.
Thanks for coming.
Bye.